But today we speak of traversing 1,000,000 miles of empty space where there is no north nor south, no rising nor setting sun, not even any up or down. It's an extremely complicated task requiring many, many measurements. To learn about the guidance and navigation system which will make this possible, we talked with Mr. Eldon Hall, Deputy Associate Director of the Instrumentation Lab.
The guidance and navigation system consists of two measurement elements, controls, a computer, and a computer display and controls. The inertial measurement unit, shown up here but normally mounts back, consists of gyros and accelerometers that measure the angles and velocity of the spacecraft in this fashion. The spacecraft rotates, the inertial measurement unit holds the reference so that angles can be measured. The sextant is an instrument very similar to that used by the sailors to navigate on the surface of the Earth.
Now, what kind of a problem might you have to solve?
The most basic problem is to determine the position at any point in time, and that can be illustrated in these charts. The sextant shown here represents the spacecraft. To determine the position, an angle must be measured between a point on the Earth and a star. And you can see that as you move away from the Earth, this angle would narrow down, thus giving the distance between the Earth and the spacecraft. The astronaut first positions the spacecraft so that a point on the Earth, a landmark, is visible through the sextant. Then he positions the sextant angle so that the star is superimposed upon this landmark.
What kind of a landmark might you see?
This one is San Francisco Bay, as you can see here. However, the Great Lakes or Cuba, Cape Cod, the tip of Florida, any of these points make suitable landmarks.
Then through some system of mirrors, you actually superimpose the star on that.
That's right. The mirrors inside the sextant will bring the star within the field of view. We can superimpose it on the landmark.
Now, how is this angle actually measured?
It's done automatically by the computer. The astronaut must first identify through the computer the star and the landmark he's planning to use. Then, as he's positioning the spacecraft and the sextant, the computer is measuring the angles between the two. When the astronaut is satisfied that the star is superimposed upon the landmark, he pushes the mark button, telling the computer to record these angles and the time, the measurement. From that information, the computer can compute the position of the spacecraft in space.
Mr. Armstrong, I do realize that when you were on the moon, you had very little time for gazing upwards. But could you tell us something about what the sky actually looks like from the moon, the sun, the earth, the stars, if any, and so on?
The sky is a deep black when viewed from the moon, as it is when viewed from cislunar space, the space between the Earth and the moon. The Earth is the only visible object other than the sun that can be seen, although there have been some reports of seeing planets. I myself did not see planets from the surface, but I suspect they might be visible.
When you looked up at the sky, could you actually see the stars and the solar corona in spite of the glare?
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics. I don't recall during the period of time that we were photographing the solar controller what stars we could see.
I don't remember seeing any.